Today we're going to discuss geometric sequences. So geometric sequence have a ratio between each pair of consecutive terms called the common ratio. And each term is multiplied by the previous term by the common ratio. So how's this different from arithmetic? Arithmetic was adding or subtracting, and that was called the common difference, and it was linear. So this is multiplying, has a common ratio. So what do you think it is if it's multiplying? What function did we do where we multiplied by the same thing every time? Well, I hope you're thinking of exponential. So this one's going to be the same as exponential. Now, once again, the term number, which term it is your x, and the term itself is your y. So you could put this in StatCalc 0 and make an exponential function. So if a sub n is the nth term, like we discussed a sub n, that just n stands for which term it is, so it's kind of like your f of x. A sub 1 is your first term. Now, when we did exponential, we started with our 0 term, our y-intercept. So that's the difference in this equation, which is called the explicit equation. We're starting with the 1 term. Therefore, the exponent has to take your term and subtract 1 so that we take out that 1 that we've already done. So let's first of all determine if these sequences are arithmetic, geometric, or neither. So this one, we're not adding or subtracting, so it's not arithmetic. Are we multiplying by something? Yes, we're multiplying by -4. So it's geometric. We're multiplying by -4. What if you're not sure? Some of you are having trouble with this. Take this term and divide by this one. You're going to get -4. This divided by the one in front of it, -4. This divided by the one in front of it, -4. That's going to tell you what you're multiplying by as you go this way. So let's go ahead and run the equation. A sub n equals, what does it say to start with? This is term 1, 2, 3, 4. Start with the first term, which is 1. Then start with your ratio, -4. to the n minus 1. That's how you would write the general equation for this geometric function. What about this one? It's not multiplying because it's not getting bigger or smaller really fast. So is it adding? Let's go. 15 minus 11 is 4. 11 minus 7 is 4. 7 minus 3 is 4. So yes, it is arithmetic because we are adding 4 every time. So let's go back to the arithmetic function that we learned yesterday, and let's write a sub n equals, start with your first term, which is 3, plus your common difference, plus 4, times n minus 1. There's your arithmetic formula or function. So this one here, we're not adding, it looks like we might be multiplying. 32 divided by 8 is 4. 8 divided by 4 is not 4. 32 minus 8 is 24. 8 minus 4, not 24. So this one's a neither. You have to check and see if the pattern is there for it to be a sequence.
English teachers, please check your email. English teachers, please check your email. English 1 and 2 only.
Sorry about that. Excuse the interruption. So this one's getting smaller, so we're either multiplying by a fraction or we're subtracting. So what is 5 minus 7? That's a -2. 7 minus 9, -2. 9 minus 12, -3. So isn't this one neither? I believe that's neither, because also you're not dividing. 5 divided by 7 is 5/7. 7 divided by 9 is 7/9. That is not the same. So this one's a neither. Right here, not adding, it's getting too big, too fast. So let's try the multiplying and see. Let's go 162 divided by 54. What do we get? 3. Whoops, sorry, you can't see that. Let's do 54 divided by 18. We get 3. And hopefully we don't have to put 18 divided by 6 in our calculator. Hopefully we know it's 3. So this one is geometric because we are multiplying by 3. So let's write the equation. A sub n equals, what's your first term? 6. What's your ratio? 3 to the n minus 1. So it's geometric, and here's your equation. Let's do the last one. Okay, it doesn't look like it's multiplying. It's not getting big fast enough. What is 35 minus 27? It is 8. What is 27 minus 19? It is 8. What is 19 minus 11? 8. Therefore, we are adding 8 every time. So it's arithmetic. We're adding 8. And so a sub n equals, start with your first term, plus 8 to the n minus 1. So it's arithmetic, and there's our equation. All right, let's look at the last examples. We need to write an equation. They're telling us these are geometric. And let's write an equation, then find a sub 6. So, whoa, this one's getting smaller. It must be multiplying by a fraction. So let's start this way. Let's go 6561 divided by 2187, and we get 3. So this must be multiplying by a third. So my common ratio is 1/3. So let's go a sub n equals your first term times your ratio to the n minus 1. Now let's find a sub 6. A sub 6 equals 6561 times 1/3 to the 5 power. Now why did I do that? Because it's n minus 1. N is 6. 6 minus 1 is 5. Let's put this in our calculator. Let's go 6561 times 1/3 to the 5 power, to the 5th power, and we get 27. So our 6th term, whoops, I can't write that. Our 6th term, a sub 6, is 27. That means when x is 6, y is 27. Let's look at this one. We're getting bigger, so we must be multiplying. This must be -3. So you could put it in your calculator if you needed to. -216 divided by 72 is -3. 72 divided by -24 is -3. So our common ratio is -3. Let's go a sub n equals first term times -3 to the n minus 1. So what is a sub 6? A times -3 to the 5th power, because I do 6 minus 1. So in our calculator, we're going to go 8 times -3, whoops, to the 5th power, and we get -1944. So a sub 6 equals -1944. When x is 6, the 6th term is -1944. This one's multiplying. 3 times 5 is 15. 15 times 5 is 75, etc. So the common ratio is 5. A sub n equals first term times common ratio to the n minus 1. So a sub 6 equals first term common ratio to the 5 power. So what does a sub 6 equal? We're going to go 3 times 5 to the 5th power. And we get 9,375. Because it's exponential, and remember, exponential gets really big really quickly. So this is geometric sequences.